Welcome. In this video, I am going to explain a simple problem which consists a series combination of a resistance and a inductor. Clear? Here the combination has a resistance of 6 ohm and a inductance of 0.03 Henry. Clear? This series combination connected across a supply voltage of 50 volt and 60 Hz supply. Clear? So in this problem, you have to find out the given data is written here. Only voltage is given, frequency is given, resistance is given, and the inductance value also given. So we have to find out its inductive reactance XL. We have to find out. Next, the total opposition offered to the circuit, that means impedance. From the circuit we have to find out the impedance, total opposition offered to the flow of current. Clear? Here why we are finding XL means to find the impedance value. So both are XL means both are in ohms, same units. Clear? Next, once we got the total opposition, so we can calculate what's the current, total current flowing through the circuit. Clear? We can find out current also. Next, we can find out the power factor also. Power factor we can calculate it. Clear? Next, total power we can calculate, or apparent power you can calculate. Clear? So we are going to find out these values one by one. Clear? So first, using the given data written based on the given circuit. So voltage, frequency, resistance and the inductance. From the given data, the XL value or inductive reactance value, that's XL equal to 2 pi FL, that means 2 into pi into frequency 60 Hz frequency into L value, inductance value 0.03 Henry. So we will get 11.31 ohms. The unit is ohms. Unit of inductive reactance is ohms. So now both are in ohms unit. Clear? So next we can find out the total impedance offered to the flow of circuit. So Z equal to, in RL circuit, the total opposition to the circuit Z equal to root of R square plus XL square. Here R also given, XL we calculated, so root of 6 square plus 11.31 square, we will get 12.8 ohms. This much total opposition or impedance offered to the flow of current by this circuit. Clear? So once got the impedance, we can calculate the total current. Current equal to, we know that V by Z, or V equal to I into Z. So I equal to V by Z. So V is voltage is 50 volt. So 50 by Z is 12.8. So we will get 3.906 ampere. This much ampere current is flowing in the circuit. Clear? Next we can calculate the power factor. Power factor equation also we studied. So power factor equal to cos phi equal to R by Z. It's resistance divided by total opposition. So R by Z, R is resistance is 6 ohm divided by Z is 12.8. So R by Z is 0.46875. Here I written lagging. Why lagging means this is RL circuit. So chance is lagging only or in phase. Suppose L is 0, here L is not 0, so it should be lagging. Clear? Lagging circuit, so I written lagging, power factor is lagging. Next, apparent power. Apparent power is voltage into current. So total voltage is 50 volt and total current is, we calculate 3.906, so V into I. So 50 into 3.906 is equal to 195.3 volt ampere. This much apparent power. Next is active power. Active power equal to VI cos phi. Here V is 50 and current is 3.906 and cos phi, power factor is 0.46875. So multiply, we will get 91.54 watts. Or we can calculate another method also. We know that the pure inductance dissipates zero power. So power dissipates in resistance only. So power equal to, we know that I square R equation. Clear? How much power dissipates in the RL circuit means here zero power. So power dissipates in resistance only. So this much power dissipates in the resistance only. So I square R. So I is 3.906 square into 6 ohm. We will get the same answer. 91.54 watts. This much watts we will get. So power dissipates in the resistance only. Clear? So this is a total calculation we did. So based on the given data, we started the calculation. So questions comes directly find the current. So to find the current, we should know the Z value or impedance value. So to know the impedance value, we should know the XL value, that means inductive reactance value. So we started from XL. Clear? So this is one type of problem, RL series circuit. The question will come, a series circuit which consists a resistance of 6 ohm in series with inductance of 0.303 Henry. This combination connected across 50 volt, 60 hertz supply, etc. This is one type of question. Or the same question we can ask, a inductance has a resistance of 6 ohm and a inductance of 0.303 Henry. That means a inductance has a resistance of 6 ohm and 0.03 Henry inductance. That means the same inductor has a resistance and a inductance value. That means it's an impure inductor has some resistance and the inductance. Clear? So in this type of questions, the question will come like this: a coil or a inductor. A coil consists a resistance of 6 ohm and a inductance of 0.03 Henry, like this. Or first method is directly asking the separate two elements. Clear? A resistance in series with the inductor, separate. Or else the same inductor, that means you have to know that it's an impure inductor. Impure inductor has resistance and the inductor value. So we have to indicate its resistance value and the inductor value. So we have to mark it the same one item, resistance and a inductor, which is actually one inductor element that is impure, so that it has some resistance and the inductance value. And in the third case, the question will come, a impedance Z equal to 6 plus 12.8 J ohm. A impedance Z equal to 6 plus 12.8 J ohm. This is connected across a supply 50 volt 60 hertz supply. Clear? Find the current, find the power factor, find the power, etc. So in this case, from this Z, we have to write the given data. So Z is, we know that Z is in the form of R plus XL J. Clear? So here R is 6 ohm and XL value, directly given XL value is 12.8 ohm. Clear? So from this Z, we have to write Rn, not here L value, here XL directly we can write the given data. Clear? So three format of the same problem we can ask in three format. Clear? First method is separate two elements, resistance and inductors in series with the supply. Clear? Second method is, say one coil, that is impure coil has a resistance and a inductance value. Clear? Same calculation. Again, third method is just giving the Z value. From the Z value you have to find all the other values. This Z value is series with this value connected a supply 50 volt and 60 hertz supply. So in the Z value you have to know this is R value, this is XL value. From that we have to continue the calculations. Clear? This is a simple calculation, RL based calculations. Thank you.